Welcome, AP Calculus. We are in our next lesson. This is section 2.3. We're going to look at some properties of limits. So just to review before we get into the properties, I'm going to write down a couple examples for you guys. So in this first example, we have the limit of 7 as x approaches 2. Now what that looks like, you have your y-axis, your x-axis, and the limit of 7, which means the function is y equals 7. So this guy right here is your function, and your function is 7. So I'm going to go all the way up to 7 on the y-axis, right? And I'm going to draw my graph. I don't know if you can see that blue, but I'm going to draw the graph in red. So the graph is this red line that passes through 7, and that's your function. So as x approaches 2, so now let me just put 2 on the x-axis. So as x approaches 2, looking for my pointer now. There it is. So as we get, oh, that's not the pointer I wanted. I'm sorry. Choose that one. I know there's lightsabers too. That's pretty cool. All right. So as we get closer to 2, which is somewhere here, we're saying, what's the y value? So as you get close to 2 from the right side, the y value is, that's right, 7. Okay. And as you get close to 2 from the left side, the y value is also 7. So that's why in this case, as x approaches 2, the y value is 7 of that function. So the answer is 7. So let's continue our example here so we could just write the answer. So we're going to say equals 7. So now if I were to translate this to a formula for you guys, let me choose another blue. I think this is the blue that I should have chosen for you, a little bit more brighter. We're going to say the limit of b as x approaches c is b. So that's kind of like a property. It's I know it's very abstract using these letters C's and B's, but don't worry, we're gonna go over some more examples. So here's your next example. The limit of x as x approaches 3. What is that? That is the question. So let's draw a quick graph. So if we have the x-axis, we can label the x-axis. Here we have 1, 2, 3. We know we're approaching 3 on the x-axis. The function is this guy right here. This is our function. So we're going to call that g of x equals x. So remember how to graph that function. It's, or you could think of it as y equals x. When x is 1, y is 1. So if I were to do this in red, when x is 1, y is 1. When x is 2, maybe somewhere there, y is also 2. When x is 3, y is also 3. So something like that, you could connect those dots and you get this straight line. Y equals x, this is called the identity function because whatever x is, it's the same thing as y. Identity function. So the question is, as you approach 3, so from the right side of the line, as I get closer and closer and closer to 3x equals 3, so this is 3 right here, x equals 3, what's the y value? I'm approaching the y value of 3. And From the left side, as I get closer and closer to 3, this 3 right here, when I get closer and closer to 3, I'm approaching the same y value. So the answer is 3. Well, I should be consistent. Let me write that in white, you guys. There you go. So now if I were to go to abstract, I would say the limit of x as x approaches some constant, some number, we're going to get back that same number. So that's how that looks like. There's another example that we're going to do. Don't worry too much about those properties. The more we're going to go through some examples, some more examples for you guys. If this is very abstract, don't worry. Just take a moment to breathe it in and you'll get this. Trust me, you'll get this. You guys could do this. All right, here's your next example. I got you guys. And if you guys have questions, feel free to reach out in our synchronous class. Example. Limit as x approaches c. Actually, let me start off by giving you, I was going abstract. Let me give you a concrete example and then I'll get all crazy on you guys. So let me just erase that. All right, sorry about that. So here's a concrete example. Limit as x approaches 2, but the function is x cubed. So I should have said the limit of x cubed as x approaches 2. Okay, the limit of your function as x approaches whatever you're approaching. So, all right, if we were to draw that, and we're trying to figure out what is that. So if we were to draw the x cubed function, recall from pre-calc, the graph, oh, different color. So we know what the graph is. The graph looks like this. It's a cubic function. Let me do a better job. I think like that. There you go. So that's our graph. And let me even do an even better job for you guys. Let me plug in some numbers. So if I were to plug in the number 1, when x is 1, and you're plugging that into this function, when x is 1, 1 cubed is also 1. So when x is 1, you get 1. When x is 2, when x is 2, 2 to the third power, 2 times 2 is 4 times 2 is 8. You're going to get 8. So 2, 3, 4, 5, 6, 7, 8 up here. When x is 0, you get 0. So something like this. And then likewise, -1, -2, -3, 4, 5, 6, 7, 8. 8. Connect those dots. And the question is, what happens when you approach 2? So as x gets closer to 2, on the left side, bam, you get 8. From the right side, wherever the right side of that dot is, as you get close to it, as you get close to 2, the y value, bam, 8. That's the answer. So the answer is 8. So here, now we're going to go to abstract. What we're saying is the limit as x approaches a constant, some number of x to the some number, that's the same thing as saying that constant raised to that number, right? That constant was 2, that number was 3, 2 to the third power is 8. Kind of crazy. we're going to do some more examples. All right, so let's continue. We're going to look at some examples. Before we get into those examples, I just want to point out that, where's my pen? Okay, we're going to point out that there's a couple ways of looking at limits. So we can look at limits. One of the ways is how we did in the previous lesson. We did it numerically. We did that table, and that was time consuming, but that's one way of looking at limits. Another way of looking at it, which is kind of nice, is graphically. And I showed you with the graphing calculator how to find that limit. And you also see it here in this picture, in this graph, how to find a limit, right? Using the graph. So that's graphically, using the X and Y axis. And the third way to find a limit, and that's what we're headed towards, is algebraically. Algebra, baby. And we could all do that, right? Algebraically. So I love this. I love the algebra part. Love that class. So let's do some problems. Example. So, well, before we get to this example, let's call what this is. We're gonna do this method. This first method that I'm gonna show you is called plug and chug. Plug chug. So in this example, you have the limit of 2x minus 1 as x approaches 3. No more table, no more graph, just plug in the number and get your answer. So x approaches 3. So wherever you see an x, just plug in 3. And that's the answer. That's plug and chug method. We'll do one more plug and chug and we'll move on. So here's another plug and chug example. Let's say the limit of x squared minus 3x minus 10 over x plus 2 as x approaches 1. So same concept, wherever you see an x, just plug and chug. So we have 1 squared minus 3 times 1 minus 10 over 1 plus 2, which is 3. So we have 1 minus 3 minus 10 over 3. 1 minus 3, negative 2 minus 10, negative 12. Did I do that right? Check my math, please. And that is negative 4. All right. That's the answer for that example. So we're done with plug and chug method. Wasn't that easy? You guys got this. You guys could do this. All right, next example. Let me just move up a little bit. So we're done with plug and chug. Leave that there if you still need that. All right. The next method is called factor and simplify. Factor and simplify. Uh-oh. Do you guys remember how to factor? I hope you do. If not, it's a little review right now. It's a little review. Okay, so here we go. Example. So if you have the limit as x approaches 5. Oh no, I should have said the function. The limit of the function, which is x squared minus 3x minus 10 over x minus 5 as x approaches 5. All right, so for this type of problem, just want to point out something before you think about trying plug and chug. Plug and chug is your go-to method. But when you plug in a 5 into here, right? Plug in the 5 into here, you're going to get in the denominator, 5 minus 5 is 0. You can't have 0 in the denominator. That's undefined. So the question is, how do you handle those types of problems where you have an undefined function? And the way to handle that is to factor the problem. So whenever you're doing plug and chug, you got a fraction and you have if this denominator turns into 0, you have to, well, breathe a little bit, just relax and be like, okay, how else could I solve this? And that's part B. Factor the problem, simplify it out. So let's see if we could factor this out. All right, so I'm gonna change colors here, do some algebra. So in this limit problem, we're gonna say the limit, could I factor the numerator? X times x is x squared, 5 times 2 is 10, and I wanna get a -3, so this should be -5 and this should be +2. -5 plus 2 is -3, all over x minus 5. So what'll happen when we factor out the x minus 5s, we're removing the problem, right? We're removing the situation that causes us to have an undefined function. So once you remove the problem, as x approaches 5, you could find the limit. Once you remove the problem, you can find the limit. So the limit then of x plus 2 as x approaches 5, oh, well, there's a 1 there, but it's okay. Just now you could try plug and chug. Go back to plug and chug. 5 plus 2 is 7. So 5 plus 2 is 7, and that is your answer. I want to show you what that looks like graphically. So you understand that let me go back to my pointer. So you understand that this function, the x squared minus 3x minus 10 over x minus 5, is the same function as x plus 2. The only thing that we did is we removed the problem, but it's the same function, right? It's the same function. So let me share my screen, my different screen here. I want to show you graphically how this looks like. So I think that will help some of you guys who are visual learners. I'm going to show you with decimals. I think decimals might do a better job with this. All right, so I'm going to type this in. Here we go. The function was, do we remember the function? Yes, it was, let's call it f. The function, and we need the fraction, x squared minus 3x minus 10. Nope, not what I want. All over x minus 5. So that's how the graph looks like, right? I'm gonna zoom out for you guys. Now, as x approaches, we were approaching the number 5, and we got 7 as the answer. So if you look at the graph could be deceiving because you might think that at 5, the answer is defined. But if you click here, it's undefined, right? The denominator, if you plug in 5 in the denominator, you're gonna get 0. However, we're approaching 5. And so as from the right side, you're getting closer to 5, you're gonna get the y value of 7. You're approaching 7. From the left side, you're approaching the y value, 6.5, 6.6, 6.7, 6.8, 6.9. You're approaching 7. Even though it's undefined, it's okay. We're approaching 7. So that's how that graph looks like. Now, if I were to draw another equation for you, let's say the other equation, when we simplified this, it was x plus 2. Oh, my bad. Let's call this the g function. Equals x plus 2. Same function, right? Same function as the purple one. The only situation is we removed the problem. We took away the x minus 5. So now at 5, as you get close to 5, the function is defined. Oh, that's the purple one, my bad. Black. So as you get close to 5, the function is defined. The answer is 7. But when you have that fraction, that was a problem when we got to 7, undefined. Okay, so that's, that's, I wanted you guys to see that when you factor this fraction, you'll get another, when you factor this fraction, you'll get another equation, but the problem was removed. Okay, and the two graphs look the same. Purple and black look the same. All right, so let me go back to my notes. All right, so now let's do another factor and simplify. Factor and simplify. Here we go. Example. Oh no, it has to be white just to be consistent. All right, example. So we have the limit of the function. The function is x cubed minus 1. That's a 3. That's a 3. Let me fix that for you. Don't want you to make a typo. 3, x to the third power minus 1 all over x minus 1. All right, so in that problem, you could do as x approaches 1. All right, so you could do plug and chug, but what happens when you plug in a 1 in the denominator? This whole denominator becomes 0, right? And that's undefined. That's a problem. So we have to factor. We have to use a different tool, and the tool is factoring. So here we go. We're going to factor this out. So it's the limit. So every time you got to write limit, the moment that you stop writing limit, it's not a limit problem anymore. It's a different type of problem. It's like something else you created. So we are dealing with limit problems. So you have to write the word LIM. This is a limit as x approaches 1. However, the numerator, we're going to factor that out. So this is a difference of cubes. So whenever you have